This is Chapter 9, Problem 58. In this problem, we're going to have two blocks that are going to interact with each other in an inelastic collision, and then they are going to compress a spring. The first block has a mass of 2 kilograms, a velocity of 4 meters per second. The second block has a mass of 1 kilogram, and it is at rest, so its initial velocity is 0. Let's go through the momentum conservation for an inelastic collision. So P initial is equal to P final. The first mass has all the velocities, so 2 kilograms multiplied by 4 meters per second, and that's equal to the total mass. It's an inelastic collision, so the two objects will stick together. 2 plus 1 kilograms, so 3 total kilograms, and we have some final velocity, V final. V final is then equal to 2.67 meters per second. Now we have the velocity, and we're going to go through the energy conservation to figure out the compression of the spring. The change in kinetic energy will bring the block to rest, and that will be equal to the work done by the spring. The blocks begin with a velocity, which we're going to use for the kinetic energy, 1/2 the mass of the system, 3 kilograms, multiplied by the velocity that we found previously, 2.67 squared. That will bring the blocks to rest, so the final kinetic energy will be 0. The work done by a spring is 1/2 kx squared. They give us the spring constant, which is 200 newtons per meter, multiplied by x squared. And finally, we have the compression of the spring is 0.33 meters. To recap, we started out with an inelastic collision, which we used to figure out the final velocity of the two blocks after the collision, 2.67 meters per second. We then went through energy conservation. The kinetic energy of the two blocks will change. It will go to 0 because it brings them to rest. So we start out with all kinetic energy. That goes into the work done by the spring. We use that to solve for the compression of the spring, 0.33 meters.